What is software anyway? Good question. Well, it's a big topic, so you can go as high level or as deep as you want. Let's stay simple here. Typically, it starts with a bunch of code, software code. And since it's mostly written by human, well, it has to be something human can easily do, which means text, lots of it. This text gets then converted into a long series of one and zeros because, hey, that's the kind of things computer feel at ease with. And once it's done and it runs on a computer, things will happen. Anything you want it to do or anything you can do. It could be sending data on a network. That's typically what happens when you send a web page or play a video on YouTube. Or it could be to compute numbers. That's what Excel does. Or whatever you want. It can drive a car, land a jet, or remind you to go grocery shopping. It's always the same. You start with code and you end up with some behavior you wanted to achieve. Well, as we'll see in this series, there is quite a bit more in between, but that's for later. Now, when we talk about software, most of the time we actually talk about applications. Hey, do you like this new application on your phone? That application is pretty buggy, and so on. So, what's an application? Well, it is a specific application of a software program to a given task. That's as easy as that. That's why we call it an application. And those applications can live in many places and be of very different type. Some are what we call desktop application. They will be specifically installed to work on your computer, on your laptop. Others might be mobile application. It's the same thing as a desktop application because your phone is essentially just a smaller computer that you use when you're bored to use a computer. And so that would be Instagram or TikTok. Essentially, mobile is a kingdom of procrastination. Or they could work within a browser. The browser could be on your phone or on your desktop. It really does not matter. The important thing here is that a web application does not get installed on your computer. It's not where it lives. It's shipped in real time from a remote web server anytime you want to use it. Isn't that amazing when you think about it that you have those applications live streamed to you whenever you hit them in just seconds or less? And then there are applications that you actually do not see. There are many of them. Who knows? Maybe they are actually the majority of applications. They work as daemon in the background somewhere in the dark alley of a data center or in a box somewhere. Think about applications that would be operating dams, for example, or safety features in your car, in your bank, the electricity grid, or a nuclear plant, your home automation, traffic lights. They are simply everywhere. Think about it. Most of the time, we only see the tip of the iceberg with those applications. Every day we benefit from application, but we actually never see them. Another way to classify application is to think about them as being connected application versus standalone application, meaning are they expecting or do they need to have access to a network to work properly? Back in the days, most applications were not connected because, well, networks were rare and the internet was not a thing. But these days, a vast majority of applications are connected, at least in some fashion. The most obvious example of this is, as we just discussed, a web application. When you are using a browser to reach a website, you are always connected to some remote machine to load some content. But sometimes it might be more subtle, but it's still very real. Even desktop applications typically connect to a machine somewhere to validate that you paid your software, for example, to check whether an update is available. Even cars nowadays get regular updates, live streamed, and can send video clips of what went wrong to further improve their software. The bottom line is that we are in a very connected world these days. It is rare to have software that can simply run on its own with no dependencies on anything else. It's becoming a huge mesh. And as you can imagine, there is not far from a huge mesh to a huge mess. So let me just seed that hint for now. Just keep it in mind. Another concept you'll frequently hear about when talking about connected application is the notion of client and server. are we in a bar or what? No, no. Simply put, a client will be an application that requests something. Could be a web page, a video, anything really, to a remote application, which we call a server that will serve that request. So yeah, it's kind of like in a bar, except that the response time is expected to be faster, much faster. The goal is essentially to centralize on a server a bunch of features that many clients will need. So many clients accessing a server and making requests, such as many web browsers accessing, say, Amazon.com as a website. At this point, keep in mind that we're talking about a logical server, just a thing that you will access from a client. If you have worked with computers in the past, you know that we also call a server sometimes a physical big wonky computer, right? It sits in a data center. But the reality is that you never quite know which physical server you will be accessing. You just see a logical server, some kind of logical endpoint. Let me translate this. If you are using your web browser from your phone to access Amazon.com, this Amazon.com is really a virtual thing. There is not one massive, big physical machine called Amazon.com. When your request hits Amazon, it will be handled by any of the hundreds of thousands of physical servers that sit behind that logical thing. And it even exists on multiple continents. And that's the beauty of it. As a client, you do not need to care about any of that complexity. That's none of your business as long as it works. And that now makes it possible for us to lift the corner on the possible complexity of an application. Take Twitter, for example. From the outside, at a high level, it is simple. You have twitter.com or whatever the name of the service is these days, and a bunch of clients accessing twitter.com. But if you actually double click on this twitter.com box, this graphic you see here is actually a highly simplified view of the architecture of Twitter in 2022. And each box you can see here probably has plenty of sub boxes and sub boxes. And ultimately, each of those would run on dozens, hundreds, or maybe thousands of physical servers. So when you start double clicking on things, you discover that the world is a lot more complicated than it seems at first. For example, there are dependencies across all of those things. Say that I will change the way a server operates, for example. Well, I have to potentially also change the clients as well, right? And all of them. So what do I need to update first? And what happens if my client is not updated and still access my updated server? And if my application has a security issue, one of them, can I quickly update it, or do I need to update some other application first? Is there some kind of cascade, some order I need to respect? Who would know that? Is that a person in the basement who has this magnificent knowledge, or is that a spreadsheet that lives somewhere? Or maybe this is all automated anyway. Damn, this is getting really complicated. Maybe, just maybe, could we have some tools that could help with some of that? Hey, that's an interesting idea. We could even think about creating a company to deal with those kind of issues. That's really interesting.